Today I am going to discuss about the definite integrals, 𝗧𝗦𝗔𝗧 𝗧𝗧. Definition: let f of x be a function defined on closed interval ab if integral of f of x dx is equal to capital F of x, then f of b minus f of a is called the definite integral, and it is denoted by integral of a to b f of x dx. The real number small a is called the lower limit and the real number small b is called the upper limit. Definition: integral of f of x dx is equal to capital F of x plus c. That implies integral a to b f of x dx is equals to f of x plus c over the interval, closed interval ab. That is, first substituting upper limit f of b plus c minus lower limit f of a plus c, that is equals to f of b plus c minus f of a minus c, and c term will get cancelled, f of b minus f of a. Integral of a to b f of x dx is equals to f of b minus f of a. First property, integral of a to b f of x dx is equals to integral of a to b f of t dt. Integral of a to b f of x dx is equals to minus integral b to a f of x dx if a is less than c is less than b, then integral of a to b f of x dx is equal to integral of a to c f of x dx plus integral of c to b f of x dx. Integral of a to b f of x dx is equal to integral of a to c1 f of x dx plus integral c1 to c2 f of x dx plus and so on plus integral of cn minus 1 to cn f of x dx plus integral of cn to b f of x dx, where A is less than C1, C1 is less than C2, C2 is less than, and so on is less than, Cn is less than B. Integral of 0 to A f of x dx is equal to integral of 0 to A f of a minus x into dx. Integral of a to b f of x dx is equal to integral of a to b f of a plus b minus x into dx. Integral of 0 to integral of minus a to a f of x dx is equals to 2 into integral of 0 to a f of x dx if f of minus x is equal to plus f of x and is equal to 0 if f of minus x is equals to minus f of x. Integral of 0 to 2a f of x dx is equals to 2 into integral of 0 to a f of x dx if f of 2a minus x is equals to f of x and is equals to 0 if f of 2a minus x is equals to minus f of x. Integral of 0 to a f of x dx is equal to 2 into integral of 0 to a by 2 f of x dx if f of a minus x is equal to f of x 0 if f of a minus x is equal to minus f of x. Integral of a to b x into f of x dx is equals to a plus b by 2 into integral of a to b f of x dx. If f of x is a periodic function, with period t, integral of 0 to nt f of x dx is equal to n into integral of 0 to t f of x dx, where t is least positive real number. Integral of mt to nt f of x dx is equal to n minus m into integral of 0 to t f of x dx. Integral of minus 1 to plus 1 sin inverse x by under root 1 minus x square plus cos inverse x by under root 1 minus x square dx. Pi by 2 pi 2 pi 3 pi by 2. Solution: integral of -1 to 1 sin inverse x by root over 1 minus x square plus cos inverse x by root over 1 minus x square dx is equals to integral of -1 to +1 pi by 2 into dx. Here pi by 2 is constant, taking outside integral -1 to 1 dx, that is equals to pi by 2. Integral dx is x, up, lower limit 1, upper limit plus 1. Now substituting pi by 2 into upper limit, first substituting upper limit 1 minus lower limit minus 1, that is equals to pi by 2, 1 minus of minus plus 1, 2, 2 get cancelled, that is equals to pi. Pi mana solution. So second option is the right. Since in inverse trigonometric functions sin inverse x plus cos inverse x is equals to pi by 2. Angle is same here, x by root over 1 minus x square, and cos inverse angle also x by root over 1 minus x square. Therefore sin inverse x plus cos inverse x is equals to pi by 2. Next problem, integral of -1 to 3 tan inverse x by x square plus 1 plus tan inverse x square plus 1 by x dx options: first option pi, second option 2 pi, third option 4 pi, and fourth one solution. Given integral -1 to 3 tan inverse of x by x square plus 1 plus tan inverse of x square plus 1 by x dx. That is equals to integral of -1 to 3 tan inverse of x by x square plus 1 plus cot inverse of x by x square plus 1 dx. Since tan inverse x is equals to cot inverse of 1 by x, tan inverse x is equal to cot inverse of 1 by x. And here tan inverse of x square plus 1 by x. Now దీన్ని మనం x గా కనుక తీసుకుంటే tan inverse x is equal to cot inverse 1 upon x. 1 upon x, the denominator goes to numerator. Cot inverse of x by x square plus 1, that is equals to integral of -1 to 3 pi by 2 into dx. Since tan inverse x plus cot inverse x is equal to pi by 2. Tan inverse x plus cot inverse x. Here x angle is the same. రెండు ఫంక్షన్స్లో సేమ్ యాంగిల్ x. Here x nothing but x by x square plus 1. Here also x is x by x square plus 1. That's why you can apply in the formula tan inverse x plus cot inverse x is equals to pi by 2. That is equal to pi by 2 constant, and taking outside integral -1 to 3 dx, that is equal pi by 2 into integral dx x, and -1 to 3, that is equal pi by 2 into x upper limit minus lower limit minus of minus plus 1, that is equal 4, that is equal to 2 pi. 2 pi. Second is the right answer, second option. Next problem. The value of I is equal to integral of 0 to pi by 2 sin x plus cos x whole square whole divided by under root 1 plus sin 2x dx is first option 0, second option 3, third option 2, fourth option 1. Solution. Given I is equal to integral of 0 to pi by 2 sin x plus cos x whole square whole divided by under root 1 plus sin 2x dx, that is equals to integral of 0 to pi by 2 sin x plus cos x whole square whole divided by under root, and this 1 can be written as sin square x plus cos square x. Trigonometric ratio identity formula sin square x plus cos square x is equals to 1 plus sin 2x can be written as 2 sin x cos x. Sin 2x formula 2 sin x cos x, that is equals to integral of 0 to pi by 2 sin x plus cos x whole square whole divided by, let us take this function as sin x, a square plus b square plus 2ab, we can write it as under root sin x plus cos x whole square, and the square and root function will get cancelled into dx, that is equals to integral of 0 to pi by 2 sin x plus cos x whole square whole divided by sin x plus cos x into dx. In this square term, one term get cancelled, that is equals to integral of 0 to pi by 2 sin x plus cos x into dx f1 of x plus f2 of x, sum of two functions. Now integral of individual functions 0 to pi by 2 sin x dx plus integral of 0 to pi by 2 cos x dx. Integral sin x is minus cos x 0 to pi by 2 plus integral cos x sin x 0 to pi by 2. Now applying upper limit minus lower limit cos pi by 2 minus cos 0 plus upper limit minus lower limit sin pi by 2 minus sin 0. Cos 90 minus cos 90 0 minus cos 0 value 1 plus sin 90 value 1 minus sin 0 0, that is equal minus of minus plus 1 that is equals to 2 is the required solution. 2. Third option is the correct option. Next problem, integral of root 2 by 3 root 3 by 2 root 3 by 3 dx by under root 4 minus 9x square pi by 6 pi by 12 pi by 24 pi by 36. Solution. Integral of root 2 by 3 root 3 by 3 1 by under root 4 minus 9x square into dx. within the root function, it is x square term. We can make it into a perfect square. Integral of root 2 by 3 into root 3 by 3, 1 by, can take 9 common, 4 by 9 minus x square into dx, that is equals to integral of root 2 by 3, root 3 by 3, 1 by root of a into b, root a into root b, 1 by root 9 is 3, 1 by 3 into 1 by under root 4 by 9 can be written as 2 by 3 whole square minus x square dx, that is equal 1 by 3 constant taking outside, integral of root 2 by 3, root 3 by 3, 1 by under root 2 by 3 whole square minus x square dx, integral of 1 by under root a square minus x square into dx is equal to sin inverse of x by a. Sin inverse of x by a formula. Now applying that is equals to 1 by 3 into sin inverse of x by a. X by a, here a is 2 by 3, root 2 by 3 lower limit, root 3 by 3 upper limit. 1 by 3 into sin inverse of 3x by 2, root 2 by 3, root 3 by 3, that is equals to 1 by 3 into sin inverse of upper limit 3 into root 3 by 3 by 2, sin inverse of lower limit 3 into root 2 by 3 whole divided by 2. 3 get cancelled, 3 cancelled, that is equals to 1 by 3 into sin inverse of root 3 by 2, root 3 by 2 sin 60 degrees, sin 60 degrees is pi by 3 radians, minus sin inverse of root 2 by 2, 2 can be written as root 2 into root 2, 1 by root 2, sin inverse of sin x, sin inverse of sin x is x, pi by 3, minus sin inverse of 1 by root 2, sin 1 by root 2 can be written as pi by 4, pi by 4. That is equals to 1 by 3 into LCM 12, 4 pi minus 3 pi. That is equal 1 by 3 into pi by 12, that is equal to pi by 36. It is the required solution. Fourth option. Given problem root 2 by 3 integral root 3 by 3 dx by root over 4 minus 9x square. Solution. Integral of root 2 by 3 to root 3 by 3 1 by under root 4 minus 9x square dx. Integral of root 2 by 3 to root 3 by 3 1 by convert 9 taking x square coefficient making as unity. That's why 9 is common within the root. 9 here there is no 9. That's why dividing by 9, 4 by 9 into minus x square is equals to integral of root 2 by 3 to root 3 by 3. Outside the root 9 will become 1 by 3 into 1 by under root 4 by 9 can be written as a perfect square 2 by 3 whole square minus x square dx. 1 by 3 integral of root 2 by 3 to root 3 by 3 1 by root over root 2 by 3 x whole square minus x square dx. It is in the form of integral of 1 by root over a square minus x square dx, formula sin inverse x by a. Now applying this formula, 1 by 3 into sin inverse x is here, x by a 2 by 3, limits to root 2 by 3 to root 3 by 3. Simplification, sin inverse of 3 goes to numerator, 3x by 2, limits 1 by 3 sin inverse of 3 into, in place of x substitute upper limit by 2, minus sin inverse of 3 into lower limit root 2 by 3 by 2, and that is equals to 1 by 3 sin inverse of sin pi by 3. Root 3 by 2 can be written as root sin 60 degrees value, root 3 by 2 sin pi by 3 minus root 2 by 2, 2 can be written as 1 by root 2 into root 2, numerator root 2, denominator root 2 will get cancelled, 1 by root 2, sin inverse of 1 by root 2, and next 1 by 3 into sin inverse of sin x, sin inverse of sin pi by 3, in place of x pi by 3 here, sin inverse of sin x is x, minus sin inverse of 1 by root 2 sin pi by 4, sin inverse of sin x in place of x pi by 4, and take LCM 12 and simplification, we will get pi by 36. Integral minus 1 to 1, 1 by 1 plus x square whole square dx. Options, solution, integral of minus 1 to 1, 1 by 1 plus x square whole square dx. Now substitution method, put x is equal to tan theta, differentiating with respect to x, 1 is equals to secant square theta into d theta by dx, then cross multiplying dx is equal to secant square theta into d theta. Whenever if you are substituting another variable, the limits also changes. X is equal to lower limit minus 1, that implies minus 1 is equal to tan theta. Therefore, tan theta is equal to minus 1, and this can be written as tan of minus pi by 4, tan of minus pi by 4 minus tan pi by 4, minus tan pi by 4 value 1 minus 1, tan theta equal to tan of minus pi by 4, theta is equal to minus pi by 4, and next x is equal to upper limit 1, that implies tan theta is equals to plus 1, and 1 can be written as tan pi by 4. Therefore, theta is equals to pi by 4. Now the integral becomes integral of, and when you are substituting x is equal to minus 1, theta is equal to minus pi by 4. So minus pi by 4 lower limit. So upper limit x is equals to upper limit, theta is equals to upper limit is pi by 4. 1 by dx, dx is equal to secant square theta into d theta by 1 plus x square is tan square theta whole square, that is equals to integral of minus pi by 4 to pi by 4 secant square theta d theta whole divided by 1 plus tan square theta is equal to again secant square theta, and it is having a square whole square, that is equals to integral of minus pi by 4 to pi by 4 secant square theta whole divided by secant square theta whole square secant power 4 theta into d theta. In this, two terms of secant square theta get cancelled. 1 by secant square theta is equals to, that is equals to integral of minus pi by 4 to pi by 4 1 by secant square theta into d theta, that is equal to integral minus pi by 4 to pi by 4 1 by secant square theta is cos square theta d theta. Cos square theta is equals to integral of minus pi by 4 to pi by 4 1 plus cos 2 theta by 2 d theta, since cos 2 theta is equals to 2 cos square theta minus 1. 1 plus cos 2 theta is equal to 2 cos square theta. Then cos square theta is equal to 1 plus cos 2 theta by 2. So instead of cos square theta 1 plus cos 2 theta by 2, 1 by 2 constant, integral of minus pi by 4 to pi by 4, 1 plus cos 2 theta into d theta, that is equals to 1 by 2 into integral of d theta theta plus integral of cos 2 theta sin 2 theta by 2. Lower limit minus pi by 4, upper limit pi by 4, that is equal 1 by 2 into pi by 4 minus lower limit minus of minus plus pi by 4, upper limit minus lower limit plus 1 by 2 into upper limit sin of 2 into pi by 4 minus of minus plus sin of 2 into pi by 4. That is equals to 1 by 2 into pi by 4 plus pi by 4 pi by 2 plus 1 by 2 into sin 90 plus 90 sin 90 1 plus 1, that is equals to 1 by 2 into pi by 2 plus 1 pi by 4 plus 1 by 2, that is equals to 1 into pi by 2 pi by 4, 1 by 2 into pi by 2 pi by 4 plus 1 by 2. First option minus 1 to plus 1, 1 by 1 plus x square whole square dx. Solution minus 1 to 1, 1 by 1 plus x square whole square dx. Substitute in place of x, x is equal to tan theta. Differentiating the given x is equal to tan theta with respect to x, derivative of x1 is equal to secant square theta, derivative of tan square theta, secant square theta into d theta by dx. Dx is equal to secant square theta d theta. And x is equal to lower limit, then tan theta equal to minus 1. Therefore, minus 1 is tan of minus pi by 4 minus tan pi by 4. Tan pi by 4 value is 1. That's why tan theta equal tan of minus pi by 4, theta equal to minus pi by 4. X is equals to 1, tan theta is equals to 1, and tan of pi by 4, theta is equal to pi by 4. Now the integral becomes integral of, when we are substituting x is equal to minus 1, theta is equal to minus pi by 4. The integral becomes in terms of theta minus pi by 4 to x is equal plus 1, theta equal to pi by 4 dx. Dx is equal to secant square theta d theta by 1 plus x square. Here x is equal to tan theta, x square tan square theta, 1 plus tan square theta whole square, that is equals to minus pi by 4 to pi by 4 secant square theta d theta by 1 plus tan square theta is equal to secant square theta whole square secant power 4 theta d theta, 2 times cancelled, that is equals to integral minus pi by 4 to pi by 4 1 by secant square theta d theta minus pi by 4 to pi by 4 cos square theta d theta, 1 by cos secant square theta is equals to cos square theta minus pi by 4 to pi by 4 cos square theta is equal to 1 plus cos 2 theta by 2 into d theta. You know formula cos 2 theta is equal to cos square theta minus 1. 1 plus cos 2 theta is equals to 2 cos square theta, but we have to required cos square theta value 1 plus cos 2 theta by 2. Here denominator 2 constant, 1 by 2 constant taking outside, minus pi by 4 to pi by 4 1 plus cos 2 theta d theta. Now substitute integration, integral 1 d theta is d theta plus cos 2 theta integration sin 2 theta by 2 minus pi by 4 to pi by 4 1 by 2 into first upper limit minus lower limit. For this function upper limit is pi by 4 minus lower limit is minus pi by 4, minus of minus plus pi by 4. Next plus 1 by 2 constant sin 2 theta sin 2 into theta upper limit substitute in place of theta pi by 4 minus lower limit is negative sign minus of minus plus sin 2 into pi by 4 2 times cancelled, sin pi by 2 plus sin pi by 2, you know sin pi by 2 is value 1, again plus sin pi by 2 value again 1, so 2 into 1 by 2, 2 times, 1 time get cancelled, that's why 1 by 2 into pi by 2, pi by 4, 1 by 2 into 1, 1 by 2. So pi by 4 plus 1 by 2, integral of 0 to a root over a square minus x square dx. A square by 4, first option, second option pi a square, third option pi a square by 2, and fourth option pi a square by 4. Solution: integral of 0 to a root over a square minus x square into dx. Root over a square minus x square formula x by 2 into integration of same function a square minus x square plus, here a square has a positive sign, you can write as a square by 2 into root over a square minus x square, it's a formula sin inverse of x by a, lower limit 0, upper limit a, that is equal, first applying upper limit, substitute upper limit a by 2 into root over a square minus a square 0 plus a square by 2 into sin inverse a by a, sin inverse of a by a is 1, upper limit minus lower limit 0 by 2, in place of x 0, 0 by 2 into a square minus x square a square, 0 by 0 into anything value 0 plus again 0, that is equals to a square by 2 into sin inverse of 1 sin 91, that is pi by 2, that is equals to pi into a square by 4. Fourth is the right option. Integral of 0 to a square minus x square dx, and here options are there. Now integral of 0 to a square minus x square dx is equals to root over a square minus x square formula, integral of root over a square minus x square into dx formula, x by 2 into integration of as it is function plus a square by 2. A square has a positive sign, that's why a square by 2 into sin inverse of x by a, lower limit 0, upper limit a, first substituting upper limit minus lower limit, upper limit substituting a by 2 into root over a square minus a square 0, 0 into this part is 0, plus, that's why 0 plus a square by 2 into sin inverse of x by a by a 1 minus lower limit sin inverse of 0 by 2 0 plus sin inverse of 0 by anything 0, sin inverse of sin 0 0, so that's why 0. Now a square by 2 into sin inverse of 1 can be written as sin 90 degrees, sin inverse of sin x is equal to x, in place of x here 90, pi by 2 radians, a square into pi a square by 2 into 2 4. Integral of 0 to pi by 4 tan power 4x plus tan square x dx, tan power 4x plus tan square x dx is equals to options, first option 1, second option 1 by 2, third option 1 by 3, and fourth option 1 by 4. Solution: integral of 0 to pi by 4 tan power 4x plus tan square x dx, that is equals to integral of 0 to pi by 4, you can take tan square x common, tan square x, here first term is tan square x plus 1 into dx, that is equal to integral of 0 to pi by 4 tan square x into 1 plus tan square x is equal to secant square x dx. that is equal integral of 0 to pi by 4 tan square x can be written as the tan x whole square into secant square x dx. You know the formula, integral of that is equals f of x whole power n into f dash of x dx, f of x whole power n plus 1 tan x whole power 2 plus 1 by 2 plus 1 limits 0 to pi by 4. Since integral of f of x whole power n into f dash of x into dx is equal to f of x whole power n plus 1 by n plus 1. That is equals to 2 plus 1 3, 1 by 3 constant, taking outside tan cube x limits 0 to pi by 4. That is equals to 1 by 3 into first upper limit tan cube of pi by 4 minus tan cube 0 to integral of 0 to pi by 4 tan power 4x plus tan square x dx. Solution, integral 0 to pi by 4 tan power 4x plus tan square x dx, 0 to pi by 4 integral tan square x common diste remaining first term tan square x plus 1 into dx, tan square x into 1 plus tan square x is equal to secant square x, integral of 0 to pi by 4 tan square x ni tan x whole square ga raskochu. So secant square x dx, tan x is taken as f of x function. Power n is here, n is equals to 2, f of x whole power n into derivative of tan x is secant square x. This is f dash of x. So applying this formula, f of x whole power n into f dash x into dx is equals to f of x whole power n plus 1 by n plus 1. Here f of x is tan x, power n is here in place of n is equals to 2. Derivative of f of x, nothing but derivative of tan x is secant square x, that is f dash of x. Applying this formula, f of x whole power n plus 1 by n plus 1, that is equals to 1 by 3 into tan x whole cube, tan cube x integral of closed 0 to pi by 4 intervals, that is equals to 1 by 3 into tan cube of upper limit, substitute upper limit first and then minus lower limit tan cube pi by 4 minus tan cube 0, pi by 4 value 1, tan pi by 4 value is 1, 1 minus tan 0 0, that is equals to 1 by 3. Next problem, integral of 0 to pi by 4 e power tan x whole divided by cos square x dx. Options, first option e minus 1, second option e power minus 1 minus 1, third option e power minus 1 plus 1, fourth one e power minus 2 minus 1. Solution, integral of 0 to pi by 4 e power tan x by cos square x into dx, integral of, and this integral becomes integral of 0 to pi by 4 e power tan x into 1 by cos square x is equal to secant square x into dx. Put tan x is equals to t. Substitution, derivative of tan x secant square x into dx is equal to dt. ఎప్పుడైతే మనం వేరే వేరియబుల్ని డమ్మీ వేరియబుల్ సబ్స్టిట్యూట్ చేసామో దాని లిమిట్స్ ఆఫ్ ద ఇంటిగ్రల్ ఆల్సో చేంజెస్. ఇఫ్ x is equals to 0, then x is equal to 0, substitute here tan 0 is equal to t, tan 0 0, therefore t is equals to 0, x is equal to upper limit pi by 4, then tan pi by 4 equal to t, tan pi by 4 value 1, t equal to 1. Now the integral becomes integral of x0 t also 0, x pi by 4 t is equal to 1, e power tan x is equal to t, e power t into secant square x dx is equals to dt, that is equals to integral 0 to 1 e power t dt. Integration of e power t is again e power t, and substitute limits 0 to 1, that is equal to e power upper limit is 1 minus lower limit e power 0, e power 1 e minus e power 0 value 1, e minus 1, that is the required solution, e minus 1, first is the right option. Integral of 0 to infinity to a power minus x minus b power minus x dx. Integral 0 to infinity to a power minus x minus b power minus x dx is equal to integral of 0 to infinity to a power minus x dx minus integral 0 to infinity to b power minus x dx. A power minus x integration a minus a power minus x by log a minus a power minus x by log a limits 0 to infinity to minus integral of b power minus x dx. ఇదే విధంగా సేమ్ b power minus x ని డిఫరెన్షియేట్ చేస్తాం, దాని ఇంటిగ్రేషన్ a power minus x dx is equal to minus a power b power minus x into dx is equal to minus b power minus x by log b minus b power minus x by log b limits 0 to infinity. Upper limit minus lower limit, upper limit 0, numerator 0 by log a plus minus lower limit anything power 0 1 minus minus 1 by log a, before negative minus of minus plus 1 by log a, minus of minus plus upper limit 0 minus lower limit 1 by log b. So 1 by log a minus 1 by log b. Next problem, integral of 0 to 1, 1 plus e power minus x into dx minus 1, second option 2, third option 1 plus e power minus 1, fourth option 2 minus e power minus 1. Solution, integral of 0 to 1, 1 plus e power minus x into dx, that is equal to integral of 0 to 1, 1 into dx plus integral of 0 to 1 e power minus x into dx. Integral 1 dx is x, limits 0 to 1 plus integral e power minus x by minus 1, 0 to 1, upper limit minus lower limit 1 minus 0 plus minus 1 into e power minus x 0 to 1, that is equal to 1 plus of minus minus upper limit e power minus 1 minus e power 0, 1 minus e power minus 1 minus of minus plus 1, that is equal to 2 minus e power minus 1, fourth option. Integral of 0 to 1, 1 plus e power minus x dx, integral of 0 to 1, 1 plus e power minus x dx, integral 1 dx plus integral 0 to 1 e power minus x dx, integral dx is x, 0 to 1 limits, integral of e power minus x integration e power minus x by its x coefficient minus 1, so by minus 1, minus this is numerator is positive, denominator is negative, positive by negative, negative, e power minus x limits 0 to 1, upper limit minus lower limit 1 minus 0, 1 plus of minus minus e power minus upper limit 1, e power minus 1 minus lower limit e power 0, e power 0 value 1, so that is equal to 1 minus of e power minus 1 minus e power minus 1 minus of minus plus e power 0 value 1, that is equal to 2 minus e power minus 1. Next problem, integral of 0 to pi by 2 e power sin square x into sin 2x into dx. E first option, second option e plus 1, third option e minus 1, fourth option 2e plus 1. Solution, integral of 0 to pi by 2 e power sin square x into sin 2x into dx. Put sin square x is equals to t. ఇక్కడ మనం ఆలోచిస్తే sin square x ని డెరివేటివ్ చేస్తే sin 2x ఫామ్ అవుతుంది. సో డెరివేటివ్ ఆఫ్ sin square x 2 sin x into again derivative of sin x cos x into dx is equal to dt. That implies 2 sin x cos x is sin 2x into dx is equals to dt. Limits x is equals to 0 lower limit, that implies t is equal to lower limit x value ni t sin square is x is equal to t lo substitute cheste sin 0 0, therefore t is also is equal to 0. X is equal to upper limit pi by 2, that implies substitute pi by 2 in function t is equal to sin square x sin 91 1 square 1, t is also equal to 1. Therefore the above integral becomes integral of 0 to 1 e power sin square x is equal to t ga తీసుకున్నాము, e power t into sin 2x into dx is dt, that is equal integral e power t integration e power t limits 0 to 1, that is equal to substitute upper limit e power 1 minus lower limit e power 0, that is equal e power 1 is e power 0 value 1, e minus 1 is the required solution. e minus 1 అనేది ఆన్సర్, ఈ ప్రాబ్లంకి ఆన్సర్ అవుతుంది. ఇంటిగ్రల్ 0 to pi by 2 e power sin square x into sin 2x dx. Solution integral 0 to pi by 2 e power sin square x sin 2x dx. ఇక్కడ మనం ఏ ఫంక్షన్ని టీగా కన్సిడర్ చేయాలనే దాన్ని ఇక్కడ sin 2x dx కనిపిస్తుంది, కాబట్టి sin square xని టీగా కన్సిడర్ చేసుకుంటే దీని డెరివేషన్ చేసామనుకోండి, sin square x డెరివేటివ్ అంటే 2 sin x f of x whole power n డెరివేటివ్ n into f dash of x whole power n minus 1 into again derivative of f of x f dash of x. ఆ ఫార్ములాని మనం ఇక్కడ యూజ్ చేసినట్లయితే sin x whole power n 2 into sin x whole power 2 minus 1, that is sin x into derivative of sin x cos x into dx is equal to dt. 2 sin x cos x value sin 2x into dx is equal to dt. ఎప్పుడైతే మనం సబ్స్టిట్యూషన్ చేసినామో ఆ తర్వాత లిమిట్స్ కూడా ఆటోమేటిక్గా చేంజ్ అయిపోతాయి, లిమిట్స్ చేంజ్ అవుతాయి. x is equal to lower limit 0, then substitute in the variable, put a sin square x is equal to t, lower limit sin 0 0 is equal to t, therefore t is equals to 0. X is equal to upper limit pi by 2 sin pi by 2 sin 90 degrees value 1 square 1, therefore t is equals to 1. Now the above integral becomes integral 0 to 1 e power sin square x is t into sin 2x dx is dt, that is e power t integration e power t lower limit 0 upper limit 1. Now substitute upper limit minus lower limit e power 1 e minus e power 0 1. Next problem, integral 0 to pi 1 by 1 plus sin x into dx. First option 1, second option 2, third option minus 1, fourth option minus 2. Integral of 0 to pi 1 by 1 plus sin x into dx, that is equal 2 into integral of 0 to pi by 2 1 by 1 plus sin x dx. Since integral of 0 to a f of x dx is equal to 2 into integral of 0 to a by 2 f of x dx, if f of a minus x is equal to f of x, that is equal 2 into integral of 0 to pi by 2 1 by 1 plus sin pi by 2 minus x dx. Integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. Integral of 0 to a f of x dx is equal to integral of 0 to a 1 by 1 plus sin pi by 2 minus x, that is equal to 2e into integral of 0 to pi by 2 1 by 1 plus sin 90 minus x cos x dx, that is equal to 2e into integral of 0 to pi by 2 1 by 1 plus cos x 1 by 1 plus cos x is equal to 2 cos square x by 2 into dx. Here denominator 2 numerator 2 cancelled, that is equals 0 to integral of 0 to pi by 2 1 by cos square x by 2 is secant square x by 2 secant square x by 2 dx. Integral of secant square x by 2 is tan x by 2 tan x by 2 by 1 by 2 0 to pi by 2, that is equal to 2e into applying upper limit minus lower limit tan of x by 2 x place లో pi by 2 ని సబ్స్టిట్యూట్ చేస్తే pi by 2 by 2 pi by 4 minus tan lower limit 0, that is equal to 2 into tan pi by 4 value 1 minus 0, that is equals to 2. Second is the 2 is the solution of the given problem. Integral of 0 to pi 1 by 1 plus sin x dx. Integral of 0 to a f of x dx is equal to 2 into integral 0 to a by 2 f of x dx. If f of a minus x is equal to f of x, here a is pi, f of x is 1 plus 1 by 1 plus sin x, f of x is equals to 1 by 1 plus sin x, that is f of a minus x, f of pi minus x is equals to f of 1 by 1 plus sin 180 pi minus x, that is equal to 1 by 1 plus sin 180 minus theta sin theta, that is equal to f of x. F of a minus x is equal to f of x, then the integral becomes integral 0 to a 0 to pi f of x dx is equal to 2 times of integral 0 to a by 2, here a is pi, a by 2 is pi by 2, 1 by 1 plus sin x dx. Now that is equal to 2 into integral of 0 to pi by 2 1 by 1 plus sin of pi by 2 minus dx. Again one more formula, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That is equal to 2 into integral of 0 to pi by 2 1 by 1 plus sin 90 minus theta formula undi sin 90 minus x cos x dx 1 by 1 plus cos x formula 2 cos square x by 2 dx. 1 by cos square x by 2 dx is equal to 1 by cos square theta is secant square theta into dx. Integral of secant square x by 2 is tan x by 2 by 1 by 2 0 to pi by 2 1 by 2 the numerator కి వెళితే 2 అవుతుంది. tan of upper limit pi by 2 x place లో pi by 2 సబ్స్టిట్యూట్ చేస్తాము, pi by 2 by 2 pi by 4 minus lower limit tan 0 tan pi by 4 value 1 minus tan 0 0 2